So hi everyone. In this session, a couple of weeks ago, I just added this page, which is very cool about Go channel use cases. I saved this page weeks ago, and I just find a time to revisit these use cases. I see it is very cool, and I thought that if we do that together, it will be cooler than I expected. So in this session, we will read these channel use cases. If you want to see something more about Go channels, so you can just visit my YouTube channel, and then there are a couple of videos about this Go channels. So here, we will do a live coding session, of course, but let's read the description about the first channels, use case for channels. So the first one is return receive only channels as a result. Basically in this part, in this example, the return type of the function is added as channel. As you can see here in the example, they says that, let me rephrase this one. There is a function which is called sum squares. Most probably you pass some values to this function. And then instead of doing this iteratively, it will just execute this one in a concurrent way, so that you will get the results for this execution. I don't know, you don't need to append these total execution times, respective execution times, but instead you will get it faster. Here there is a main function, and as you can see in Go, you can just create it is something like tuples. You see on the right hand side there are two phrases, and on the left hand side you see there are two variables. So the first function will be assigned to A here, and the second function will be assigned to B here. So sum squares, when you have a look at the parameters here, sum squares, it gets the two integers, right, and it returns an integer result, and basically it is a square plus b square, and that's it. Very simple function, but it may seem a bit complicated to you at first, but in the description they say that receive only channels. So in Go channels, there are directions. You can receive from the channel, you can write to channel, so think about the channel. You can write something to that, you can read something from it, or in both way, you can just read and write to the channel. So you can do both of them. And here, as you can see, there are some squares, and we are passing, we need to pass an integer here, right, in this function. But as you can see, there is some statement here. This A, as you can see, long time request returns a channel here, and when you do this, the arrow on the left hand side, so left arrow A, you are saying that just get the value from the channel. So basically you are passing some values to channel, and then you can read it from the channel. It is something like queue. You can put some item to the queue, and then you can read it from that. In this part, it is creating a channel with a type. So channel is another variable type in Go. So here I am saying that there's a channel. Think about there's a pipe. You can put an integer inside it. And I am creating a channel here. There is a Go function. In Go, you can just create a function statement, and you can directly execute it in a concurrent way. So if you want to make a function execute concurrent, then you can just put or prepend a Go to that function statement. Here there is a channel, there is a concurrent function. We are saying that return R. You basically return a channel here, and it should be a receive only channel. And then here you are saying that okay, there is a sleep here. Basically you are sleeping for 3 seconds, and they are saying that you are just simulating the workload, and you are putting a value inside here, which is round int something. So there will be a random value, So we are passing a value to this channel, putting a value into channel, but if you do not read it, then it will block the execution. Yeah, you can just have a look at here. This is the link of the documentation. And let me generate a project here, and we can also try it. Maybe if we need, we can also debug it. Go channel use cases, go mode 8. Where are you? / go channel use cases. Go channel use cases. Okay. Can we say if a Go app doesn't have a Go routine and channel, it is not good enough, or it should have them? Can we say if a Go app doesn't? No. It is, you don't need to have so if you have a Go application, it does not mean you need to have a channel or something like that. It is all about the use cases. So let's say that you are doing a calculation. I mean, you are generating a PDF, right? And when I send a request to your REST API for the PDF generation, you need to return something to me. It is not an async operation. That is my use case. Then you don't necessarily need to have a Go channel in this application. Using channels in Go is not something like makes you cool. Okay, configure Go SDK. Main. Switch. Twitch. Okay. So what can I do is I can just define another functions here, and or let me do something like this. I will create another Go file here, receive only squares. I need to open my fan. So here okay, we have a function here which is called long time request, and the return type of this one is channel type of integer 32 here, and when we go to the description, it will be make means just initialize with the default values, and that's it. And then there will be a Go statement here, func, and inside the func there is just time.sleep, and the duration will be time.second multiplied by 3, and which means 3 seconds, and you are saying that just pass a value or put some value to this channel integer, but this time will be, yep, this one, and okay, and return channel r. This is our function, and there is a squares. Sum squares means the sum of the squares of two numbers. Integer 32, and here as a return value it will be this one, return a.a plus b. So we will call this one inside our sum square. Okay. Let's say that this will be sum square, but at the same time I will add a function here. Let's say that it will be run. Run will not take a parameter in this case. I will say run.seed time.now.unix nano, this one, and I will say long time request and another long time request, b long time request. So we can assign this one to two variables, b. Okay, now we can use these variables as in the statement, empty println sum squares, and you need to read values from here. Okay, b. Okay, this is run function. Okay, let me create a directory here, receive only squares. I will put this one here to make it a different package. When you have a look at here, receive only squares. In the main function I will say that receive only squares that run. So that's it. Here, let us run this function. So here we can put something like this. There is a function execution, right? Let's say that time okay, let's say that now is equal to time.now, and here we can also print this statement, time.since. You can just provide the initial part, and then we can see what is the actual time passed between these executions. So you see actually within the original function here, okay, yeah, you see within the original function long time request there is a 3-second execution, that it is a simulated workload, and here you see we are calling this one 2 times. When you have a look at non-concurrent way, you will see, okay, it will take 6 seconds, right? Because one of them takes 3 seconds. But here, since we are executing this go function in parallel and concurrently, then that means it will not take up to 6 seconds, right? Because they will run nearly in parallel. That means you will get something less. So you can easily use Go routines in Go, but you need to be careful about this. When you try to execute them, then there should be some communication channels. So you are running them, you are just executing them in a concurrent way, but somehow you need to understand that when it is finished, right? So that is why we are using channels here. So you are creating a channel, and it is assigned here, but if you do not read it, it will block the sequence. And this is how we use it. And receive only is very simple here in the example. Okay, let's switch to the next one. Pass send only channels as an arguments. So here, return receive only channels as a result. Pass send only channels as an arguments. This time, okay, be careful about this. Here, from the channel, you are reading something, right? Let's say that in the channel there are a couple of values. When you say left arrow, basically you are just popping up a value from the list. So the strategy is first in, first out. So when you put a value and when you try to read it, you will get the first value first. And in the pass send only channel as an argument, you see the arrow is on the right hand side. Still the arrow is showing the arrow left, but the location is on the right hand side. In the first example, it is on the left hand side, but in send only channels, it is on the right hand side, as you can see here. Let's say that there is a invisible stuff here. You are putting this invisible value into the channel. This is just how they simulate it. Nearly same function, most probably we will just copy it, and then let's copy it. This time send only channels. Directory send only channels. Okay, and let me create a Go file here. Send only channels, and I will copy everything from here to send only channels. Okay. Let me close this down. So in the second example, same as the last example, in the following example, the values of two arguments of the sum square function call are requested concurrently. Different to the last example, the long time request function takes a send only channel as a parameter instead of returning a receive only channel result. Okay, let's try to have a look at here. This time, where are you? Send. Okay, it will be different, right? Long time request. Let's revisit this part. Long time request, as you can see, there is no return value because we are sending something to this channel. That means we need to delete this part, and in the function parameter there will be a channel, and this will be a send only channel, and the value is same. I mean the data type. As you can see, we don't need to initialize a channel because it is already initialized here, and there will be no concurrent execution here because it will be handled in return in the main function. So let me try to just reformat this. So this is just seems how can I say, a synchronized method, but we are just passing some values to this channel. Okay, and the second is same, sum squares a b. Okay, this part will be a bit different. This one, yeah. RB. Let's create two channels here. Change, make channel integer 32, and there will be make channel integer 32. Okay, and we will just execute two concurrent functions. Go long time request, and there will be RA. Okay, go long time request, and there will be RB. And okay, let it be here, sum squares RA. Change RA RB. let me comment this part and send only channels that run. Murat Mirgin, thanks for subscribing with Prime, by the way. Okay, let's analyze this part. There's a long time request function and it accepts a channel as a parameter, and this is a send only channel. Yeah, it can also be handled by only one channel actually. Okay, let's see if there is any other go send only channels examples. Okay, the send only channel function used to send data to channel. Okay, this is a send only channel. Done. Channel. So we are passing a channel here. If the send only channel function try to receive data from the channel. Example. So there is a send only channel, but okay. But you are trying to read it here. Yeah. Okay. So in this example, you define a channel as a parameter. Here you are putting a value inside it, you are sending value to channel, but here you are trying to read something from it, so you will get an error here. Let's check same here. You are sending some value, putting some random value into the channel, so whatever you pass, when you pass your channel, it is very simple. You just pass a channel as to your function. So this is a channel. When you put it there, and inside the function, we just send the random value to this channel. On this point, on line 23, actually you are passing a channel that contains no values inside it. But when you run this function, you will see a random value will be sent to the channel, the first channel. And let me check again. Yeah. And then when you execute the second concurrent function here, the second channel, which contains no value at line 23, there will be a value after this execution, because you see whatever you pass here, we just put some value inside this channel. So on this point, both of the channels will have a value inside it, and when you try to read it from this part, you will see, you will just read the value, and that's it. Okay, we already executed this one. In both way, you see the execution time is not something like 6 seconds. It's 3 seconds here. Okay, let's switch to third example then. It says that you can also do this with one channel. That's why, because you see, you create one channel, you go to here, it will put one value inside it, and when you execute the second function, there will be another value inside it. So when you go to the eighth line, you will see there will be two values inside the channel. When you read it from here, you will pop one value from there. When you read the second element, you will get the second one. It's up to you. This kind of data aggregation, which will be introduced specially or specifically, okay, doesn't matter. The first response wins, so it seems a bit different. This is the enhancement of the using only one channel variant in the last example. This is the enhancement of the using only one channel variant in the last example. Sometimes a piece of data can be received from several sources to avoid high latencies. Sometimes a piece of data can be received from several sources. Okay. For a lot of factors, the response duration of these sources may vary much, even for a specified source. Its response durations are also not constant. To make the response duration as short as possible, we can send a request to every source in a separate coroutine. Only the first response will be used, other slower ones will be discarded. Okay, very good use case, right? Think about this. You just have a job execution. It can be anything. It can be some kind of big data analysis. It can be some parse operation. Maybe you are crawling something, and you are sending this operation to different sources, and you are saying that, okay, could you please execute the same job on your side? So let's say that there are 3 workers. You are sending these values to 3 workers, and whoever finishes it first, and they will return the result. I will get the first result, and then I will totally ignore the remaining ones, even you finish it successfully. I think this is very good use case. You can just simulate it in very easily, I hope. Note, if there are n sources, the capacity of the communication channel must be at least n-1 to avoiding the corresponding discarded responses being blocked forever. So using Go routines is very easy in Go, but in most of the use cases, you may get this kind of locks. And we need to be careful about this. Let's analyze this example, but first response wins. Let me create a package. First response wins. Go file. First response wins. So you see why you are creating different packages on this. That's because I just wanted to make it visible to direct visitors. So I will push this one to GitHub. So when you open the main Go, you will see, oh, there are some run functions calling here, and you can uncomment whatever you need, and then you can run it. That's it. So the next one will be something like first response wins, but there is no function at all. Okay. So let's try to understand this first. Start time now. Okay, they are using our notation time since to print the time interval between the execution start and end. Start time now. C must be a buffered channel. Okay. Okay. When you just initialize a channel, as we do here, channel, you can say that you can put as much as value here. You are free. But here you see there is a restriction. Make channel, this is the data type, and 5. You can put at most 5 items here. We can just try to, okay, let me do this. Func run, and inside the run, okay, let's put this run seed to make random time now and Unix now. Start time is equal to time.now, and here we are seeing that make same data type chan There's one, and so this is a method overloading, right? Here, when we try to go to the implementation, you will see what was the shortcut when I go to implementation, go to declaration, go to simple. Okay, I couldn't find this show documentation. Anyway, let me close this part. The make built-in functionality allocates and initializes an object of type slice, map, or chan. You see slice, map, or chan only, so you cannot make it another data type. Like new, the first argument is a type, not a value. Unlike new, makes returns type is the same as the type of its argument, not a pointer to it. The specification of the result depends on the type. So slice, okay. And then you see the size specifies the length. The capacity of the slice is equal to its length. Okay, if you put some, let's say that the data type is not chan and it is slice, then it means that there will be at most 5 items inside it. In the channel, the channel's buffer is initialized with a specified buffer capacity. If it's 0 or the size is omitted, the channel is unbuffered. Okay. And here the size is 5. Fair enough. Let's try to do a for loop here. Zero. Cap save. Oh, I never used this cap before. Okay, I will analyze it. Let me go this cap. The cap built-in function returns the capacity of V. Ah, okay. Okay, cool. So it will return the capacity. I just solved this function, by the way. I never needed to use this one before. Go source C. Okay, there is no such a function. Let's create function source. C channel in 32. Okay. B is equal to run. There is no seed. Run and +1. So it seems there is no such a okay, there will be no n here. Okay, time.sleep, time.duration RB, and the second one time.second. RA. Okay, so let's read it. There is a channel here, but it will be a send only channel, right? You can just write to this channel only. I am creating 2 random values here, a random value and the random value plus there is a 3 here, 3 int n. That's one. Okay, and we are putting a, so whatever the random value is, we will just sleep at that time, and we are trying to write this value to here. So if it is 2, there will be 2 second sleep here, delay, and then we will put this 2 as a value to this channel. That's it. And what else? Here there is a run. Okay, we are trying to read something from C, but let's check it. Here we are saying that just make a channel, since there is no direction, you can write something to it or you can read from it, right? So I am reading from C, and when I see some value, I am assigning it to rand variable, and just print it. The value time dot since start time, and just print the rand value. Okay, let's reformat it. So here, let's revisit it. We already understood this part, right? We are generating two random values based on these found random values, RB, and we are just putting a delay. Then we are putting this delay value into the channel. This is a send only channel. Here we are making a channel with a capacity of 5, and we are starting our iteration from 0 until to capacity of this channel, which is 5 on our case. So it will be 0, 1, 2, 3, 4, and for every number we are calling this source function, and you see this channel, it is same. We are passing always the same channel here. Okay, cool. So let's say that you are generating random values on each time. Let me tell you something here. Let's say that so this function will be called 5 times, right? Here, let me try to write something. So first execution, the value is, let's say that 2 seconds. The second, let me write it down here. The second execution, the value will be, let's say that 1 second. Third execution, the value will be, let's say that 4 seconds. And fourth execution, the value is, let's say that 1.5 seconds. And the final execution here, it will be this time, let's say that 5 seconds. Okay, so at the end there will be 5 execution running concurrently, and here you run this one in a concurrent way, and then for every execution there will be some delay, right? The delays will be 2 seconds, 1 second, 4 seconds, 1.5 seconds, and 5 seconds. So which one out of these 5 execution will return the value first? Return means we are waiting for the delay value, and then we pass this value to channel. As you can see, this one, because this is the smallest one, that means there will be smallest delay in the function, and on the second iteration here, it will return the value. Return means not there is no return, but the value will be written inside the channel first, and then we will get this value, right? Whoever reads the value from the channel, it will wins. So, and if you put some values into channel, and if you do not read it, you will see the operation will be blocked. So let's say that you put this value here, and there is no send to channel operation, and then you will see this operation will be blocked forever. Can we try it, by the way? Here, okay. Let us try to run this function. Main. First is not means. Let's run this. Okay, deadlock, because there is some channel read operation, but actually you are sending nothing to this channel. Let me uncomment these parts. Okay, and run it again. Okay, you see the first one, the maybe it will be better to write the found random values, so it will be more visible. Before calling the function, I will print this one, println, and no, not this one, sorry for that. So when I find some numbers here, I will say RB. Okay, let's rerun this one again. Okay, you see 1 1 3. Oh, we set RB, but we didn't print the precision of this one. Okay, anyway, so here 1 2 3 4 5, there are 5 values here, 5 delay seconds. As you can see, the smallest ones, this one, or this one. But since I just print the RB value here, there is no precision. Maybe I need to print here I can say that empty.printf, there will be value something like dot I am just trying, by the way, here RB okay, let's try this. No way. I think I'm in the right direction, but I couldn't find what is these values. No. Shame. Anyway, I couldn't just print these values after the rounding these digits, but I hope that you just got the point. Let's switch to fourth one. More request response variants. The parameter and result channels can be buffered so that the response sites won't need to wait for the request site to take out the transferred values. Sometimes a request is not guaranteed to be responded back. Sometimes a request is not guaranteed to be responded back a valid value. For all kinds of reasons, any error may be returned instead. For such cases, we can use a struct type like. Okay. So let's say that this is the response type, struct. There will be a value, it can be anything, like something like generics, and there can be an error. So when you have a look at the response, you will see a data plus you will see an error field. If there is a data, you will see it in the field here as inside the V, but the error most probably will be a nil in Go. Okay. Sometimes, for some reason, the response may need a much longer time than expected to arrive or will never arrive. We can use the timeout mechanism introduced below to handle such circumstances. So it is saying that when you send a request, you may get some response, but if the operation takes too much time, then you can just there can be a timeout mechanism for that. Sometimes a sequence of values may be returned from the response side. This is kind of the data flow mechanism mentioned below. Okay, so here there are another use cases. Notifications can be viewed as special request response in which the responded values are not imported. Yes, that's true. You are sending some value to channel, and then if somebody reads it, then it is a request response, right? Something like that. Generally, we use the blank struct type as the element types of the notification channels. For the size of type struct is 0, hence value struct doesn't consume memory. Okay. One-to-one notification by sending a value to channel. If there are no values to be received from a channel, then the next receive operation on the channel will block until another go routine sends a value to channel. We already mentioned about this. You are trying to read something from channel, but actually there is no one sending to this channel. So somehow there should be a separate go routine that tries to send a value to this channel. So we can send a value to a channel to notify another go routine which is waiting to receive a value from the same channel. So we can send a value to a channel to notify another go routine which is waiting. Okay. In the following example, the channel done is used as a signal channel to do notifications. Okay. So 101 notification. Let me create another package for that. 1, 2, 1 notification and new go file 1, 2, 1 notification. There is a main function, and then that means there will be only run function. Run. Okay. Here values make byte and the capacity. Okay, there is a values variable. The main content here is the byte. There will be byte array here, byte, and the size is byte kilobyte, 32 kilobyte. Dirt multiplied by 174. Okay, so run.read values. Okay, multiple choice. Let's try to import it. Mat random. Is that? No, it should be crypto random, as in the example. Okay, you see there is a warning here. Most probably we need to handle the error, right? We can use this notation or explain in the statement, doesn't matter. There is an error, there is a read, correct, but instead of return we will say, okay, instead of saying this one we will also say fatal F. But we don't need a F here, and error. Okay, if there is an error we will just throw an exception, okay, and the process will quit here. I am creating another channel which is make another type of chan struct. Okay, this is different, right? Because we always use integer, but this time it will be a struct. I'm creating another go routine here, and inside it there will be a sort.slice. So from the sort package you can just sort the values inside slice, which is values in this case, and I, the first one, I, j, integer bold. Okay, here you just define your strategy for providing what will be the sorting strategy of your slice. Here I am saying that values j. Okay, I am directly, so here after sort operation we need to notify our channel. Here I am saying that struct. Okay, then we are done, right? And print values first, values len values on this one. Okay, let's try to run function first, but where do we use this read? Okay, we don't care about the value of this read. In main function I will comment this one and say 1 2 1. Oh, the package, okay, this is very bad package name. Refactor rename 1 2 1 notification. As well. Yes. Okay. Here 1 to 1 notification run and analyze afterwards. Zero. So it prints the first value and the value at the location of the last index, right here. Okay, we can have a look at this one. Run read. Read is a helper function that calls reader read using our readful. Okay. So there are some values inside it in this slice. In values, right? It contains byte array and the capacity is 32 kilobyte in this case. And here, as you can see, there are some Go routines. We are calling this one only once. So you see there's a function description, and when you put this open and closed parentheses, it will directly be executed in concurrent way. As you can see here, Go field. And we are sorting this slice, which is values, and this strategy is here. When you do this I, j, you are saying that it will be sorted in a ascending way. I will be less than the j, so the first item will be less than second item will be less than the third item, something like this. And when you sort the slice, you actually saying that okay, just send some value to this one. So as you can see here, done. There is a struct. Is that correct? Yes, it is correct. This is a struct. Type of channel contains struct, and this is struct type. But you are saying that when you pass this one, the open and close the curly brackets, you are saying that this is a struct with no value. It is used because it has no meaning inside Go in terms of memory. That's it. We are sending this one to done because let's say that you are running this function in a concurrent way, and as you can see, there is a read operation from the channel. So we are reading from the channel, but you don't need to necessarily assign this value to a variable. That's fine, by the way. But since there is a read operation here, if you do not send any kind of value to this channel, you will see the operation will be infinitely blocked. Just an example, if you do this one and try to run this function again, You see, it is just totally blocked because no one is sending value to this one. Okay, just close this again and uncomment this one. That's how we are doing the notification system on this case. By the way, we are also writing a in-memory database in Golang in our sessions, live coding sessions, and we already implemented map data type. So we are storing hash maps inside the database, and in the upcoming data types there will be queue notifications. So think about this. There is a consumer on the client side, and you just define a queue, which is maybe channels on the server side. The client side will read some value, but since there is no value in the channel, it will be blocked entirely. That means I am consuming the queue. When you put some value inside it, you will see it will be automatically fetched on the client side. So you can use these channels to just implement a queue mechanism inside Golang. Okay, end-to-one and one-to-end notification. So this was the one-to-one communication. Let's try to implement end-to-end communication. End-to-end communication. Wrong. Here it will be communication. Refactor. N to N. Okay. So this time, yeah, there are workers, etc. Okay. By extending the above two use cases a little, it is easy to do end-to-one, one-to-end notification. Let's see. This time there is a type T struct. Okay. You are just defining a type and then you are assigning it a struct to it. Simple. There is a worker function. The first parameter is integer. The second parameter read-only channel. You see, you are reading from the channel. And the third parameter is send on the channel. If you try to read from this, you will get an exception. If you try to send something to this, you will get another exception. Block here and wait for a notification. You see, within the function, you are trying to read value from the channel, but if there is no value there, then it will be blocked. If you get a value, you print it. Worker something starts, simulate a workload, worker job done, and then notify the main Go routine. Very simple. Ready, done. There are two channels here, which is first one is for ready, second one is done. We are calling two concurrent worker function here, 0, 1, 2, ready, done. So what we do next, ready is equal to tier. Okay, for every channel here, so there is a channel. You just send this ready channel to here, here, and here. That means, so there are channels passed to here. In order to make this unblock, you need to send the first, second, and the third parameter here. You need to send it because in the first execution, it will be blocked here. When you execute the second concurrent function, it will be blocked on another Go routine. When you call the third execution, you will see it will be blocked on another third Go routine. So you have 3 Go routines and all of them are blocked due to this one, right? Because there is no value you send there. And then when you try to do done, 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 here, where is done? Done is this one. Okay. Okay, you are trying to read from it, right? So here you are saying that within this class function execution, you can only send to this channel. So you are sending a struct value to here, right? when you send it, it will be read from here. But what about this one? 1 to N notification. I'm trying to understand this difference, 1 to N, N to 1. Okay, I just got it here. So you see, this is the main coroutine, right? When you start here, the function main itself, it is another coroutine. This is the main coroutine. Main coroutine just creates 3 separate sub coroutines. Okay, and here you are saying that from the main coroutine, from the one location, you are doing 3 write operations to the ready channel. So main coroutine writes a struct to ready channel, writes another struct to ready channel, writes another struct to another ready channel, right? So from one source, which is main coroutine, you are sending these values to different coroutines. So basically from one coroutine, which is main coroutine, you are notifying multiple locations, because all of them are different channels. And here being notified, so when you try to, so all of these done values is consumed by the main coroutine, but the values are received from different coroutines. Yeah, I just understood this part. We can try to simulate this one. So I'm just defining a type T, and the initial value is struct. Okay, it can be. Then I define a worker. Inside this worker, the first parameter is integer. There is a ready channel. This will be chan T. There is a done channel. This will be a send only channel, and this is T. And after that, I am saying that ready log dot print. This is the worker dot ID. ID starts. Okay, there is a simulation here. Time dot seconds times time dot duration ID plus 1, and log dot print. Here I am saying that workers ID job done T. Okay, this is our worker function. Now we will define our run function. Log.set flags 0. Let's directly have a look what that means. Sets the output flags to standard logger. The flag bits are LDate, LTime, and so on. Okay, standard logos. Okay, it is just about logger stuff. and there will be end-to-end communication run. Here, go to implementation. Okay, there will be two channels, right? Ready, done. Make channel type of T and make channel type of T, another T. Go worker 0 ready done, and I will copy this one back, replace 2, go up, replace 1. No. Okay. Then time.sleep, duration is time.seconds, times, I don't know why this number is located something like this. Ready, and this will be T, another ready, T, and another ready. Ready, T. So let's, okay, and there will be done, and done, done. Okay. Okay, so just to recap again, when you create a Go routine and pass some channel to there, you will see here in our case there will be 3 separate Go routines, and for every Go routine there is a block operation here. So in order to make this unblock, you need to send some value to this channel, right? So there are 3 Go routines. When you execute this one, you will unblock this part. When you send this one, you will unblock for the second Go routine. When you send this one, you will unblock that part for the third Go routine. But when you try to unblock this part, you see the execution will be continued, and then the done value will be set as a struct. That means it will notify here. So you see from one location, which is main Go routine, I am notifying 3 another separate Go routines. So that's why this is one-to-end notifications. From here, after I unblock this part, they will start the execution and the done value will be set. That means multiple Go routines will notify the main Go routine. That's why this is end-to-one and this is one-to-end. Okay, let me check how many use cases there are. Broadcast, timer, mutex logs. Okay, there are lots of them, by the way. Let me check. Okay, it's already been 1 hour here. Okay, let me recap the comments and then okay. Okay, sorry for I am answering this part about the language selection. So I can say that I'm a global, I'm providing global conference. I have lots of talks in the global conferences. So the main idea of this Twitch stream channel is to trying to reach the global audience. Yes, time to time I am doing my these sessions in my local language, but time to time I have a plan to do these streams sessions in in English, because when I do Turkish, somebody asks there was any English version. Yes, time to time I am doing English, and this time somebody asks about why this is not in Turkish. So I cannot handle, or I cannot manage two channels at the same time. So that's why I am trying to do these sessions. And during the stream creation, I am just selecting the language, so you can understand that in which language it will be handled, and that's it. Yeah, let's continue these next use cases in the upcoming session. I believe that these use cases are very informative. I mean, I already use channels in my project, but when I have a look at these use cases, I thought that I know, I can say that I know only the maybe 30 or 40% of the channel, how channel works. So I am planning to revisit all the use cases here in the upcoming sessions. I don't know why, but I can do twice per week, and that's it. So thanks for listening this session, and see you in the next session for this one. Bye.